Hi guys, how's it going? This is Sierra Nalula, and today we're going to be continuing our discussion on object-oriented programming in Python. Okay, so we're going to be talking about accessing members of one class from another class. We're going to be talking about inner classes. We're going to be talking about garbage collection, destructors, and last but not least, how to find the number of references of an object. Okay, so why don't we start off by talking about how to access members of one class in another class. Okay, so accessing members, okay, here we're just talking about variables and functions. How can we use functions that have been written in another class in the class that we are currently looking at, right? So, well, we obviously need two classes, right? Because we're accessing one from the other, okay? And let me give you an example. Okay, so the first class is going to be student, okay? We're going to define our constructor, okay, passing in self, and the self obviously refers to the object, the current object. It's always pointing to the current object. Okay, we're gonna have a name, we're gonna have a grade, and we're gonna have a favorite subject. Okay. So self.name equals name, self.grade equals grade, self.favorite subject or fav sub equals fav sub. Okay, so that's how we're going to refer to the current object's favorite subject, or current object's grade, current object's name. Okay, we're just going to refer to it as name, grade, and favorite sub. Okay, cool. So we initialized a couple of variables here, and we're going to define another function, or method rather, because it's inside a class, and it's going to take in self, okay, and we're just going to print our name is self.name, what grade are you in, and then we're going to get self dot grade. Actually, it's not a question. We're just gonna say grade is gonna be self dot grade. Okay, because it's not an input, right? Okay. Print. And we're gonna print favorite subject. Okay, and it's going to be equal to self.fav sub. Okay, I said that there would be two classes, right? Because we're accessing one from the other. Okay, and this is going to be called test. Okay, because we're just testing things out right now. Okay, and we're going to define a function. We're going to define a method called modify. Okay, and we're going to take in a parameter. Okay, right now we don't know what it is, even if I say like student, like it can be anything. Okay, no connection to this class whatsoever currently. Okay, so it's going to take in student, but we're going to consider this an object of another class. So we're going to say, if you remember from previous videos, that you can access properties of classes by using the reference variable. Okay, and we're going to define a function. We're going to create an object later on. So we're going to just say student dot name. Okay, I don't know that I'm going to pass in an object from the student class. It can be any class, but I'm just going to say that the object has the property name. Okay, and we're going to change it to student.name, except we're just going to add maybe they're from like England, and we're just gonna be a little fancy and say this person of England, right? And we're just gonna do student dot display, and we're assuming that the object of whatever class has a method display. Okay, cool. And we run it and everything's good. Okay, so now we're gonna create a student object. Okay, we'll call it Tina. Okay, and it's a student object. Okay, this is the syntax, and we need to pass in these parameters, these arguments, and the name is Tina. The grade is, let's say, 10th. She's in 10th grade. And her favorite subject is science. Okay. We created a student object. Okay. And the reference variable is Tina. Okay, so Tina is an object now. Okay, its value is a student object. Okay. Cool. And now we're going to say test.modify. Okay, and we're accessing this modify by using the class name because it's not an instance method, right? Because it doesn't take in self. Okay. And we're going to pass in student. Okay, we're going to pass in Tina here. Okay. And I'll tell you why it makes sense. Okay, so what did we do here? We passed in Tina into the method modify. This is a student object, okay? So now that Tina's getting passed into modify, we're going to this method. This is Tina. So Tina.name. What is Tina.name? You have to go back to this class because Tina is a student object. Okay, we go back here and then we say Tina.name. Self points to the current object. Okay, so Tina's name, we passed in here, it's Tina, right? A string. And then we do the same for display, right? Because we're printing the name, grade, and favorite subject. Okay? So now we're printing the name that we redefined here. Just in modify, not the actual student class. And then we're going to talk about grade, and then we're going to do favorite subject. So it's going to go from Tina, okay? It's going to go from modify, right? Tina is right here. Tina.display. You have to go back to student class, go to the display method, because Tina is a student object, and we execute this code. Okay, so that is what's going on here. Hopefully it makes sense. And that's why it works. Okay. Cool. So so Tina does have, right, the attribute name. If we were to pass in another, like, if we were to create another, let's call it kid instead of student, and we were to say self, oh no, we're gonna do definite, and it doesn't take in anything other than self, and we're just gonna say print I go to school. Okay, and if we were to create Gabriella, okay, is a kid, okay, everything's good, and this constructor gets executed every time we create an object of a certain class. Okay, and then we're gonna say what happens when we do test.modify and we pass in Gabriella into it. We get an attribute error because this doesn't have the attribute name. Okay, because when we do when we pass in Gabriella, we're going to the modify, right? We're doing Gabriella.name, but we didn't initialize any variables, right? Gabriella doesn't have a property name. It has no attribute name. So this code wouldn't work out. Okay, so that's why we get an error. Okay, cool. Okay, so we just talked about accessing members of one class from another class. Okay, and hopefully you know how to do that now. Cool. So now let's talk about inner classes. Okay, inner classes. Sometimes you can define classes inside of classes, okay? And these classes would be considered inner classes, okay? So let me tell you when you might want to use an inner class. Okay, so if there is no chance that an object's existence without the existence of another object, then it would be a good idea to use inner classes. Okay, so if there's no chance that an object would exist without another type of object, then you should use inner classes. Okay, let me give you an example. Okay, so for example, you have a class engine. Okay, and this is going to be part of a car. Okay, can an engine exist without a car? No, it can't. So the class engine would be part of the class car. Okay, engine is the inner class of car. Okay, the engine class is a part of the car class. Let me give you another example. We want to create a class department, a science department. Science department. Okay. Can a science department exist without a school or a university? No, it can't, right? So the science department would be, the class science department would be an inner class of the class university. Okay? And you can do the same with other things, maybe like a human, right? You have different parts, and each of those parts are like head, liver, heart. All of those are different classes. They have so many different things about them. They have so many different functions, right? So those are all classes, but they don't exist without a human. So they would all be the inner classes of the class human. Okay? So that's what's going on there. Okay, let's do a little example. Okay? So we're going to call a class outer. Okay, we're going to define the constructor. Okay. Then we're just going to print this is the outer class. Or maybe since this runs when we create an object, we're going to say object creation, and then we're going to say outer class. Okay, let's define an inner class. Okay, this also needs constructor. We're gonna print object creation. This is gonna be part of the inner class. Okay, and we're gonna define method 1. Okay, it's an instance method, has self in it. Okay, and we're just gonna print inner class method. Okay, and similar to what I've talked about here, right, where you can have human, and then we're gonna have class head, class liver, class heart, right? Right, you can have different objects for head, for liver, for heart, all part of the human, right? So you can have an outer object, just like you can have a human object, right, in programming. So if we say O equals outer, we get object creation of the outer class. Okay. Now we're going to say I equals inner. And the way you do this is we're going to say O, right? So an object of the outer class dot inner. Object creation of the inner class. Okay. And we're just going to say I dot method 1, right? Because I is an inner object and there's a method 1 in there. We get inner class method. Okay. So hopefully that clears things up a little bit about inner classes. And let me tell you about like the different syntax you can use, right, for calling an inner class method like that. So the number 1 is where you say like, O equals outer, right? We did that just now. I equals O dot inner, and I equals method 1, right? Same as here. Okay, there's another way. Okay, you can say I equals outer, okay, dot inner, okay, and you can say I dot method 1, okay, and another way you can do is outer dot inner dot method 1, okay. So these are 3 ways you can call an inner class method, right? So it's the method is part of an inner class, which is part of an outer class. These are a couple of ways you can do that. Okay. So now let's talk about garbage collection. Okay. So in other languages, older languages, right, the programmer is responsible for creating and destroying objects. Okay, and if you don't destroy useless objects, there are going to be memory issues, and maybe the application would shut down, right? But in Python, okay, there's a garbage collector that's always like running, okay, like behind the scenes, right, to destroy useless objects. Okay, so the probability of a Python program failing because of memory issues is not very high. Okay, and also if you can also enable and disable the garbage collector in our program. Okay, so let's do that here. Let's import the module GC, okay, GC for garbage collector, okay, and we're gonna check whether the garbage collector is enabled. Okay, GC dot is enabled. Okay, this is a method that we're calling. Okay, and we get true. Okay, it returns a Boolean value of whether garbage collector is enabled or it's not enabled. Okay. And if you want to disable it explicitly, you can do gc.disable. I'm not going to do it now. Or Actually, I might. Okay, we're gonna disable it. Okay, cool. So now when we see GC is enabled, you get false because we just disabled it here. Okay, but I want to enable it again. So GC dot enable. Then we're going to check whether it's enabled again. And it is. It's true. Okay, so these are the functions. These are the methods you can call that belong to GC, the module GC, garbage collection, right? To check whether it's enabled or it's not enabled. Okay. And also, if an object doesn't have a reference variable, then that object is eligible for garbage collection. And remember, an object doesn't have to be something that you define yourself, right? There's a class, there's an int class, there's a boolean class, right, or bool, right? And 5, 6, 7, 8, these are all objects of that class. It's an inbuilt data type, right? They're all objects, right? So true is an object, 5 is an object, hello is an object. These are all objects. They don't have to be like objects that you define yourself. Okay, just wanted to make that point here. Cool. So now we're going to be talking about destructors. Okay, a destructor is a special method. Okay, and its name is going to be del underscore. And just before destroying an object, the garbage collector always calls the destructor to perform cleanup activities. Okay, destructors. So this is going to be responsible for cleanup activities. This doesn't actually destroy it, okay? It just like performs a cleanup activity. So once the destructor execution is completed, the garbage collector is gonna destroy it. Okay, it automatically destroys that object. Okay, cleanup activities. Okay, the job of the destroyer is not to destroy the object, but to perform the cleanup activities necessary before the destruction. Okay, so it doesn't actually destroy it. So we're going to define a class called destruction. Okay, def init, our constructor right here, self, we're going to print object is initialized. Okay, and you see here, the name is going to be del, right? Okay, so we're going to print performing clean up activities. Okay, just to let us know. Okay, and now we're going to say that D equals. So this is a special method here, okay? That's the name of the destructor. Okay, so D is going to equal the destruction class. We just defined the class right here. Okay, and then we're going to say that D equals none. Okay, so what I'm doing here is setting the value of the object D to none. Okay, what did I say here? I said that objects that don't have reference variables. Okay, wait, let me write that down. Objects that don't have reference variables are eligible for garbage collection. Okay, so these objects are available for garbage collection, and what I'm doing here, when I'm saying that D equals none, I'm setting it to none so that the del method is called. Okay, so it's eligible for garbage collection. Okay, Cool. So now we're going to run it, and we get object is initialized when we create this object, because the init method automatically executes, and since d equals none, it's eligible for the garbage collector, and it's performing cleanup activities. Okay? So if it doesn't contain any reference variable, it's eligible for the garbage collection, and also if the reference count is 0, then the object is eligible for garbage collection. Okay, if the reference count is 0. So now we're going to be talking about, I think it lends itself nicely into the next topic. So how to find the number of references of an object. Okay. So how to find the number of references of an object. So we're going to import the sys module. Okay. And it's all good. And we're going to define a class called test. And we don't want anything in there for now. So we're just going to use the keyword pass. Okay. And let's create several objects of that class. So t1 equals test, t2 equals test, t3 equals test. Okay. Right? Okay, so t2 equals test, t3 equals test. So what I'm going to do here is I'm going to say t2 equals t1. Okay? t2 is going to be equal to the same thing as t1. That's another way of saying that. What is t1? t1 is a test object. So t2 is t1, which is a test object. Okay, and then we're going to say t3 equals t1. We're going to say t4 equals t1. We're going to say t5 equals t1. Okay, so there are so many references to the object t1. Okay, there are so many references. And now I want to see how many references there are. Okay, print sys.get reference count, ref count, and then I want to look at t1. Again, we get 6. Alright, so because what is t1? t1 is test. So how many reference variables are pointing to test? Well, t1 is. Okay, t2 is, t3 is, t4 is, t5 is. Okay, there's 6 in total. Okay, cool. And just a last side note, for every object, Python internally maintains a default reference variable, okay, self, okay, so, yeah, okay, just wanted to put that out there. Okay, so, I think we talked about a few things in this video. We talked about accessing members of one class from another class. We talked about inner classes. We talked about garbage collection. We talked about destructors. We talked about how to find the number of references of an object. Okay, I hope you learned something new today about object-oriented programming in Python. And don't forget to stay curious.